Welcome back, everyone. Hope you had a great week. I've covered derivatives earlier, so today I'll be trying to solve problems using derivatives. We'll use a simple problem to see how derivatives can help us solve it. These are generally optimization problems. Optimization means finding either the maximum or minimum of the equation, and at what value x is optimal. Derivative is a function that shows the rate of change in the original function, right? So if the original function is about something, that thing will either be increasing, decreasing, or staying flat as x changes. And where it's flat, that means the slope or derivative value at that point has to be 0. So, let's get started with our problem. Imagine that we are given some material of total length of 100 feet. Our goal is to use that material to create a rectangle, and that rectangle should have maximum area. Let's understand the given information. Total length of the material is 100 feet. How can we create a rectangle using that? Well, we will use it to make length and width. Basically, that will be our entire perimeter for the rectangle, right? And what is a rectangle? It has 4 sides total, and opposite sides are the same side. Let's say length is x and width is y for our rectangle. Our area of the rectangle will be x times y. Times y. Our goal is to find x and y where this area will be maximum. We have x and y as 2 variables here. So we should make it into a 1 variable equation so that it becomes f of 1 variable, something like f of x or f of y only. Let's see if we can replace either x or y and make it 1 variable equation. The perimeter has to be 100 feet because that's our length of total material. And the perimeter for the rectangle of length x and width y, length x with y, is equal to 2x plus 2y. So our perimeter is equal to 2x plus 2y. So, 2x plus 2y equals 100. If we divide both sides by 2, we get x plus y equals 50. Now, we can use this equation to replace y with x. Let's subtract x from both sides. And we get y equals 50 minus x. Let's put this back into our area equation. Now, let's distribute x. Distributing it, we get 50x minus x squared. Now, we can say this is our f of x because it is in only terms of x. So, area equals f of x, which equals negative x squared plus 50x. It is basically a quadratic equation since 2 is the highest power for x. Anyway, what it means is that as x will change, the area will also change. When x will increase, area will also increase. But at some value of x, the area will not increase. It will stay flat. And then after that, the area will start decreasing even if x increases. Let's see the graph of negative x squared plus 50x. It'll look something like this. As you can see, this is the point where our area will be maximum. And that's the point where slope will be 0. As you can see, it's flat. And how do we find slope? Yes, derivative. So, what we need to do is find f prime of x and make it equal to 0 to find the x value where x will be maximum. Let's do it. So, our f of x is equal to negative x squared plus 50x. So, our f of x, or our f prime of x, sorry, will be equal to negative 2x plus 50. But how? Well, this is called the power rule. So it just means x to the power of n is equal to n times x to the power of n minus 1. This is called the power rule. So the derivative of negative x squared is 2 times x to the power of 2 minus 1, which is just 1, so just x. And that becomes minus 2x. Similarly, the derivative of 50x will just be 50 times 1 to the power of 1, and that's just 1. So that's just 50 times 1, which is just 50. Now, let's make this equal to 0. So, negative 2x plus 50 equals 0. Now, let's rearrange this so that we get 2x by itself. And if we divide on both sides, that means our x is equal to 25. But all we found is x, but we still need to find y. So let's use this to find y, which is just 50 minus x. Because look at my equation, y equals 50 minus x. So I just do y equals 50 minus x, and x is just 25. So it'll just be 50 minus 25, and that is just 25. So our y is equal to 25. And that's the two sides. This will be 25, and this will be 25. So our x is 25, and our y is 25. This means that the area will be 625 square feet. So let me just write it down here. Area equals 625 square feet. Let's have a recap of the algorithm. We find the equation of the thing like area, volume, or etc. that we want to maximize or minimize. Then we convert that equation into just a one variable using some other information that's given. See how I turned this and made it in terms of x, and then I subbed it in? Just like that. And that's our f of x. This one, right here. Then we take the derivative of it to get f prime of x. And then we make it equal to 0. And then we solve for x, which in this case we got 25. And get y and the actual value of the function itself. We can use it in many such problems. But that's all for today. We'll see you in more problems or maybe applications of integrals in the next video. Thank you for watching. See you in the next one. Bye.